Here we're going to look at one of the most simple reactions of alcohols, and that's called elimination. The reagent we use is concentrated sulfuric acid because it's a dehydrating agent. It effectively rips H2O out of the alcohol, so OH from one carbon and a hydrogen from a neighbouring carbon, to create a double bond, so to make an alkene, and of course water being our product. It's technically an equilibrium reaction, so it can go the other way as well, so we want to make sure that we're removing that water to drive that reaction forwards. The only complication with this one comes in if you have got something like butanediol. So butanediol, as shown here, there's two possible places where the hydrogen could be ripped off. There's two neighbouring carbons. So we can see we've got one here, shown by the pink circle with the hydrogen, or it could be a hydrogen off this carbon, the blue circle. Now, Zaitsev's rule is basically Markov-Nikov's rule in reverse. So Markov-Nikov's rule was the rich get richer. Zaitsev's, oh so original, is the poor get poorer. So this carbon here has only got one other hydrogen bound to it. This one has got two. So the pink hydrogen's one is poorer with only 1, 2 there. This one's got 1, 2, 3, so two others. So this one being poorer, it's more likely this hydrogen is going to be removed rather than this one. So we end up with a major and a minor product. Now just a little bit of a covering my backside here. You'll actually get two major products too, because of course this is butene. So some will be cis and some will be trans. But the key point is that the double bond is going to be formed between these two carbons more readily than between these two carbons. So we end up with a major product and a minor product. If we knew the amount of this, we'd expect about 50% to be cis, as shown here, and 50% would be trans. So just to recap, if we use a strong dehydrating agent, and in this case conc sulfuric acid is our best option, we can remove the OH and a hydrogen from a neighbouring carbon. This is called a dehydrating reaction, but we classify as elimination. Our product is an alkene. If our alcohol has two possible carbon atoms where the other hydrogen could be removed from, so this is a good example here, then we use a thing called Zaitsev's rule, saying the poor get poorer. This carbon only has two hydrogens on it, this one has three. This one is classified as poorer, so it is more likely that the double bond will be formed here, leading to our major product, shown with the pink double bond in here. You will still get some of the other product, shown by the blue double bond there, but it will only be a very, very small amount.